All right, so for number 2, we're going to be graphing this expression here. This is from lesson 11.1. If you want to look at your notes for more examples, you can. The number that's here, if we take its opposite sign, gives us our vertical asymptote. So I'm going to go over 2, and I'm going to draw a vertical line here. This number here, we don't change the sign, we keep it the same. And that one gives us our horizontal asymptote. Next, we're going to realize that since this is a positive, my curves go in the bottom left corner and in the top right corner. Now, if there was a negative up here, then it would be reversed. We would have the curve in the top left corner and in the bottom right corner, but in this case, since it's positive, it looks like that. So that's number 2. Let's go ahead and take a look at number 4. Anytime you're missing this number or the number that's over here, which we are in this case, they equal 0. So for this one, we have a 0 here. My vertical asymptote is -1. My horizontal asymptote is y equals 0. All right, so we'll go ahead and graph it. My vertical is at -1. My horizontal is at 0. Notice that this time we do have a negative in the front of our fraction there, and therefore our curve will be on the top left and on the bottom right. Number 6, we're going to simplify this expression. For the coefficients, we're just going to reduce it like we normally would. We would look for a number that divides into 20 and 30. And so if I divide the top and the bottom by 10, I end up with 2 over 3. But we also need to deal with the variables. When it comes to the variables, basically you're going to subtract the powers. So 2 take away 1. 2 take away 1 is 1. So it's going to be r to the first power, and that's going to go on the top because the bigger one was on the top to begin with. And so there's your answer. Whenever you have a polynomial instead of just a monomial, we're going to start by factoring. So since these have 3 terms, what we would do first is we would use the box method. We're looking for 2 numbers that multiply together to make a squared. That would be a and a. And we're looking for 2 numbers that multiply together to make -21. One possibility would be -7 and 3. And then we fill in our box by multiplication. So a times -7 is -7a. 3 times a is 3a. We know we're right if these 2 numbers add up to make this, which they do. Okay, so the top is factored into a minus 7 and a plus 3. We're also going to factor the bottom, once again using the box method. First term goes here, last term goes here. A times a makes a squared. 10 times -7 makes -70. Fill in your box. You know you got it right if these 2 numbers add up to make the middle, which they do. So we have a plus 10 and a minus 7. Now, I got the right answer from my box methods both times I tried, but don't be surprised if on your first try you don't get the right answer. If these don't add up to make the middle, then try switching these numbers around or try different numbers completely. Keep doing it until you get the pair that works. Okay. So that's the first step, is to factor the top and factor the bottom. The next thing you're going to do is reduce whatever they have in common there. So in this case, a plus 3 is left on the top, and a plus 10 is left on the bottom because the a minus 7s cancel out. This is kind of the same thing, but notice how big the numbers are. Sometimes you can take out a greatest common factor. So for instance, with this guy up here, 18, 63, and 45 can all be divided by 9. So what I'm going to do is I'm going to take a 9 out. Also, this one has 3 n's, 2 n's, and 1 n. So I can also take 1 n out of all of them. If I divide 18 by 9, I get 2. And if I take 1 n away from here, I get n squared. If I divide 63 by 9, I get 7. And if I take an n out of there, I'm left with 1 n. If I divide 45 by 9, I have 5. And if I take the n away, there is no more n. So we took out our greatest common factor first. We're going to repeat that same thing now on the bottom here. Once again, 18, 45, and 27 can all be divided by 9, and they also all have an n, so I can take an n out. If I divide all of these by 9n, I'll be left with 2n squared minus 5n plus 3. Now notice right away that we can reduce these. Now, sometimes they won't reduce like this. In this case, they just completely cancel each other out. But sometimes you're just going to reduce it like we did back on number 6. Okay? But in this case, they completely cancel out. So all I'm left with now is these. But we're still not done. We're going to do the box method on this now. We have 2n squared goes right here, and 5 goes here. Now, 2n times n makes 2n squared. 5 and 1 makes 5. Let's see if that works. Do these add up to make the middle? Yes, they do. So there's my answer for that one. Now we'll do the bottom one using the box method again. Do these combine to make negative 5? Well, not quite. They could make negative 5 if I made the 6 a negative, but if I did that, then this would have to be negative, and then we wouldn't have a positive here anymore. So we don't want to do that. So sometimes, in this case, as you guys can see, my guess didn't work. So I need to fix this a little bit. Let's try switching these numbers around. I'm going to put the 3 here and the 1 here, and we'll see if that makes any difference for us. So that's 2n, and that's 3n. Do these add up to make negative 5? Well, still not quite, because 3n and 2n makes positive 5. I want to be negative. Now, that would work if they were both negative, but that would only work if these were both negative. And that's actually okay, because 2 negatives do make a positive. So there's our answer. It's n minus 1 and 2n minus 3. All right. Now, as you guys can see here, nothing is canceling out. There's no terms that are exactly the same here. So let's see how this answer will look on your multiple choice test. We got the 9s to cancel out. That's nice. There you go. So yeah, just writing it just like we have it there. That'll be good enough. All right, let's move it along to our next problem. Talk about multiplication next. Now, anytime you have multiplication or division, if you're missing, if one of them's not a fraction, you can make it a fraction by just putting it over 1. The next thing we want to do is factor anything that we can. R plus 7 does not factor, and 9 minus R does not factor. The 1 doesn't factor, but this factors. We can use the box method once again. So I recognize these both need to be negative in order for this to work. I'll put some parentheses on these also. All right, so now we're ready to start canceling stuff off. Now, nothing is exactly the same. You can't cancel out the R plus 7 with the R minus 7 because those are not the same. These are almost the same, but they're backwards. Now, we talked about those. You are allowed to cancel those off so long as you put a negative there. Okay, so here's what I'm left with. I've got a negative 1 on the top. I have an R plus 7 on the top. On the bottom, we have an R minus 7. Okay, so they might write the answer like this, or they might even distribute this inside to get negative R minus 7. But either way, we're done there. So let's see how the software writes the answer for these. Yeah, they went ahead and distributed it. So there we go. That was multiplication. Let's take a look at a division problem next. Division is pretty similar to multiplication. It's just that you have a different step in the beginning. You keep the first fraction exactly the same for the first step. You change the division to multiplication, and you flip the second fraction over. The next thing you're going to do is you're going to factor anything that you can. So the 8 minus R and the 4, they don't factor at all, but the other two pieces do. For this guy, I can take a 4 out. For this guy, I would use the box method. So for the box method, it would be R squared here, negative 72 here. These add up to make the middle, so I know I'm good. All right, and then we're going to cancel whatever we can. In this case, the R plus 9s are exactly the same. The 4s are exactly the same. The R minus 8 and the 8 minus R are opposites. We're allowed to cancel those so long as we put a negative there. And everything's gone except for that negative 1, so the final answer would be negative 1. Now we're going to look at subtraction. You'll have one problem like this, I think, on the quiz where they already have a common denominator. So when they already have a common denominator, then what you can do is you can just make one big fraction, right? And you'll take the first numerator and the second numerator, in parentheses there, bring that sign down in the middle there. Now, if it's plus, all you have to do is combine like terms, but if it's subtraction, you do need to distribute this negative first, which changes the signs in that second binomial. So the ends are going to cancel out, but the 2's combine to make 4. And that's that. So you'll have a addition or subtraction problem where they don't have a common denominator also. Actually, we'll have a few of those. For this one, what makes it unique is the fact that everything's a monomial. There's no binomials or trinomials. All right, so the first thing we'll do is, if you can reduce it now, that makes things a little bit easier, possibly at the end. So notice here this second fraction has a v on the top and a v squared on the bottom. We can reduce that by subtracting the powers. 2 take away 1 is 1, so v to the first power is what will be left, and it will go on the bottom because that's where the bigger v was. Now we want to get a common denominator. The way that we can do that is by factoring these a little bit. 6 is 3 times 2, and 4 is 2 times 2. And what we want to do is we want to get these denominators to be the same. So notice that the left side has a 3, but the right side does not have a 3 on the bottom. So I'm going to put a 3 on the bottom there, which I'm allowed to do so long as I also put a 3 on the top. Notice that the right side has 2 2's, but the left side only has 1. So this one needs another 2 to match the other side, and it also needs a v to match the other side. Now they have the same denominators, a 3, 2 2's, and a v. So now what we're going to do is we're going to put these pieces together now. 5 times 2 times v is 10v. This is 12v. This is 15, and this is 12. Now, since they have a common denominator, we can add those numerators together over that common denominator. And there you go. Sometimes you could still reduce at this point. So like, maybe we could divide something out of 10 and 15. But the only thing we could divide out of there is a 5. So we could do that if you want to take out a GCF. But it's really not going to help at all because the 5 and the 12 don't reduce. So even though this is a possible way to write your answer, they'll probably write it this way since the factoring doesn't result in any kind of reducing. All right, let's go ahead and move on to number 20. All right, so no reducing needs to happen here, so we can skip that. There's no factoring that we can do or anything like that either. So what we're ready to do is get these denominators to match. Now, if you can, you factor. But like I said, these things can't be factored. N plus 6 and n plus 3. Neither one of those factor. So in order for the left side to look like the right side, it needs an n plus 3. And in order for the right side to look like the left side, it needs an n plus 6. All right. So we have 2 times n plus 3 minus that all over the common denominator. Like that. Now we're not done yet. We need to simplify. So for instance, here I need to distribute the 2. So if I distribute the 2, I get 2n plus 6. Here I'm going to have to do the box method to multiply those together. You could do the box on the bottom as well, but we don't need to. They usually won't multiply the denominators back together. But we do need to multiply the n minus 5 and the n plus 6. So here we go. N minus 5 and n plus 6. So we have n squared. Negative 5 and positive 6 makes positive 1. And then we have minus 30. Notice I put that in parentheses because there is that negative in the front of it, which we're going to have to distribute now. And at this point, we're going to combine any like terms that we can. So the 2n and the negative n, you could put those together to make a positive 1n. The 6 and the 30 can go together to make 36. And then we have that negative n squared in the front there. And there you go. Now I want to show you what the answer looks like, because I've noticed that sometimes with these questions, they'll have the numerator in a non-traditional order. So typically you do want to put the n squared in the front and the number last, but for some reason the software doesn't do that. But so long as they all match, you're good. We have a negative n squared, we have a positive 1n, and we have a positive 36. So don't be surprised if the order's off a little bit, but there it is. And that'll do it for our review today. So we'll see you guys in class.